These are some tools I've created using CAD software and a 3D printer. Most of them were created with AutoCAD. When my student license expired, I switched over to Fusion 360. This first tool is a connector remover tool. On some GM vehicles that use electric power steering, there's a connector. It's extremely difficult to get to unplug it. I've damaged several of them trying to unplug it during service. So I created this tool to help release the tab without breaking it. This photo is taken through the right front wheel well. Here we see the connector that I have so much trouble removing. The release mechanism is on the top side of this connector. You can see you have very limited space in there to get any kind of tool inside it to unplug the thing. This next picture shows the tool installed onto the connector, and you just pull down on this end here to release the tab and then pull the connector out. Here's a picture of the tool installed on the unplugged connector. This next tool is an injector slide hammer. On the GM 3.6 liter V6 engine, it uses injectors that go directly into the combustion chamber. These injectors will stick inside the cylinder head, and they can be very difficult to remove. They're also deep into the center of the engine where they're hard to access. So these are the 3D printed components. This is just a 1/4-inch bolt. This is a steel weight and a nut. And these are the 3D printed parts. What you do is, when this is stuck down in the cylinder head, is stick half this thing on there. And then this black stuff here is just a sticky strip caulk. I use it to hold that so I can reach down in there, place it on the injector. Then I have a sleeve that holds the pieces together. You can slide the weight on and the nut and just use it like a regular slide hammer and knock it out of the cylinder head. This is a picture of the injector installed down inside the engine. You have, this is an intake runner here, and the other intake runner for the other bank is here. There's the connector that plugs into the injector. This is the injector here with part of the tool pre-installed. There I'm adding the bolt in the other half. There it shows the sleeve being slid on. And then you add the weight and the nut. And there is the injector removed from the engine. There are some improvements I think could be made to this tool. One issue is, in order for this tool to work, there's normally an O-ring here and a plastic collar. In order for this thing to work, you have to remove those components. And it can be kind of tricky to get down in there to get those things out. I usually take like an X-Acto knife and just cut them off. But I could change the length here of this last part so that I didn't have to remove that plastic component, just the O-ring. I think it would be strong enough that it wouldn't blow out the bottom if I made that a little bit thinner. so I could leave the collar on, because the collar is really the hardest part to remove. The O-ring comes off pretty easily. So I think that would make it a lot easier to use this tool. I created this next tool to help drain DEF tanks. On newer diesel engine vehicles, they use an emission control system that injects this DEF fluid into the exhaust to lower tailpipe emissions. After removing the tank, I always like to drain all the fluid out. It makes it a whole lot easier to handle the tank when reinstalling it. So this tool slides into the fill port and depresses there's a flap, like a spring-loaded flap that closes so that you can't pour fluid back out of the tank. Well, this tool pushes that flap open and then allows you to tip the tank on end and pour all the fluid out. Here is a picture of the DEF tank. This is the fill port where I like to drain the fluid from. You might wonder, why don't you just pour it out of this giant hole here? Well, it's difficult to pour the DEF fluid out without spilling it all over, capturing it into a container. Also, there's a high spot on this end and a high spot on that end, so it's very difficult to get all the fluid out, especially if it's filled with dirt or some other kind of contamination, and you want to try and rinse it out with a garden hose. Then you have to get all that water out. Well, it's difficult to get it out of that hole, so it's much easier to pour it out of this. Here's a close-up of the fill port. You can see this is the flap that closes, and this is a picture of the tool installed holding the flap open, making it possible to pour the DEF fluid from that fill port. This next tool is something I made to help with filling transfer cases and axles on some of the smaller all-wheel drive cars where there's limited space to get up in there to fill them up. A lot of times you'll get containers of fluid like this, and there's no real good way to fill these things without making a giant mess. So I printed this component here, which is basically just a cap that threads on to the end of this quart container with a couple ports. This end goes down into the container fluid like that, and then you apply compressed air to this end and it pushes fluid out of this hose. So you can stick this up into the fill port in the axle or the transfer case. Okay, this last tool is an adapter I use to work on the 6T40 automatic transmission. This is a 2/6 clutch spring compressor for the 6T70 automatic transmission. I had a 6T40 show up. I thought I could use this, but the diameter is a little bit too small. So I needed one by the next day, so I went home and drew this up in CAD and printed it overnight. And I just used the 6T70 compressor on top of the adapter like this. This picture looks down inside the 6T40 transmission. This component here is the piston, the 2/6 clutch piston. This piece here with the fingers that stick down, that's the 2/6 spring. And then you have a snap ring on top here. You compress this spring, then you can peel that snap ring out. Here's a picture of the adapter setting on top of the spring. And then here's a picture of the 6T70 tool setting on top of the adapter. And then we bolt this bridge tool to where the case halves bolt together. And you just tighten this screw down that presses the compressor down. And once you relieve the tension off the spring, you can peel that snap ring out. And here's a picture of the spring removed with the adapter and the tool setting on top. I've always enjoyed making my own tools. I find it's very satisfying to create something useful. I think the 3D printer is an excellent resource for creating tools because you're able to easily create shapes and geometries that would be difficult to make otherwise. That's all. Thanks for watching.